Alright. So, we're going to look at conditional probability. Here we've got a two-way table which represents C as our Cowboys fans and T as having all your teeth. Which means that if you are not a Cowboys fan, you're C dash, and if you're missing teeth, you are T dash. So for conditional probability, it's just saying, if I already know one thing about the population or one thing about the person, about the sample, what does that mean about the other? Or what can you tell me about the probability surrounding the other? So the best way I find is to give an example. So let's say I'm at the Serena Leagues Club, and I walk up to someone and I see that they're a Cowboys fan. So they're wearing a Cowboys jersey, they've got the full kit and caboodle. What's the probability that person has missing teeth? And what is that in this context?
36 out of 41.
36 out of 41. So I would write T dash given C equals 36 over 41, and you can convert that to a decimal value. Sweet? Happy with that? For the second one, determine the probability that someone supports the Cowboys given their missing teeth. So at the same club, this person's not wearing any league kit. They're just sitting there in the area, enjoying some dinner, but I see them missing teeth. So I walk up to them and say, what team do you support? What's the probability that they're a Cowboys fan? So what I'm saying is, what's the probability someone is a Cowboys fan given their missing teeth? Can we see the difference? Same group is involved, correct? I still want to know about the Cowboys fan missing the teeth, so it's 36. What's different?
So 39.
So 39. And that leads us to our law, okay, which our law goes, the probability of T dash C equals the probability of divided by the probability of just C by itself. Now, do I have to have this just represented as numbers? So what I want you to do now before we go any further is to convert this, replace these numbers here with probabilities. So 5 wouldn't be represented as 5, it would be represented as 5 over 105. Does that make sense? Represent those as probabilities, please. You can do a new table up, or you can just simply replace those. Yeah, I'm just showing it. Oh, on this one here, no, I didn't mean to. I'm just trying to show they're interchangeable. There is slightly differences, but yeah, just be aware that the P, PR is talking about probability. That's what I'm really getting at. So with your new values, I want you to represent the probability of teeth given they're a Cowboys fan. So here I shouldn't see whole numbers, I should purely see decimals.
Oh, give it as a percentage.
Yeah, as a decimal please, decimal. It doesn't matter, but as a decimal please. Who thinks it will matter whether it's represented as a decimal or as a number, a whole number? Why won't it matter? What do I have to divide all of these terms by? 105, correct? So what's going to happen is I'm going to have the middle probability, that's going to be the same, but it's going to be divided by 105. Probability of B is going to be the same, but it's going to be divided by 105. So if we're dividing or multiplying a number on the top and the bottom of the numerator by the same value, does it change? It's an equivalent fraction, correct? So So I'm hoping that we should see the same as 5 over 41.
So do you want to hit one decimal place or?
What? Not worried. It's for your book, not for mine. 2 decimal places is an appropriate amount. That'll do.
It has to be 2 decimals, 0.0 something. 0.05.
2 significant figures then.
Can I just put that in?
Are we clear with that? What did we get? Did we get that answer or not? What is 5 over 41? What is 5 over 41? Yep.
No, by 105. Is it 105? Yeah, you divide by.
No. Okay. What's 5 divided by 105?
0.0.
Divided by 41 divided by 105. What's this number here? Just fill my table out. What's this number? It's no longer 5, it's now 0.12. 0.12? No. 5 divided by 105 is 0.12.
It's 0.05.
0.04.
Thank you. 47, that sounds better. Okay, what's 41 divided by 105?
It's 0.39.
0.39. I'm going to guess that if you shove 0.047 divided by 0.39, we will get an answer that is somewhat close to 5 over 41. It won't be exactly the same because it's rounding. What is that? So I'll put in the calculator, just humour me. What is it?
47 over
0.047 divided by 0.39.
47.
Yep, hit the SD button so I can get it into decimal.
0.12.
I see what you're all saying now. So that's 0.12. If I put 5 over 41 in, what do I get? 0.12. So we would expect to get the same regardless of whether this table is represented as a decimal or in their whole number value. Cool?
Yep.
Conditional probability is just saying I know one of the pieces of information, what's the probability about the other. If we look at this Venn diagram and this equation, so this is the equation for conditional probability, you might want to write that down. The probability of A dash B is simply the probability of A and B together, so that middle section, divided by the entirety of B. Good? Or not?
I wasn't listening what you said.
At least you're honest, that's good. I'm genuine then. The probability of A given B is saying the probability of the middle section, the part that's in black, divided by the probability of B, which is all of B. So I already know B, what's the probability of A, given that I know it's already in the category of B. Sweet? Now these don't have to be, in our example here, we have T dash, what does that mean?
Not T.
Not T, so they could also have not T, and all it would change is wherever you see A, for example, you would replace it with not T. Sweet? And on a Venn diagram it'd be different, shaded different. I'm hoping you can figure that out. Happy with that? Let's get going on our exercises. Question 1, 3 and 9 I believe we had. Or 5.3. No, I didn't. We had 1, 2, 3. Exercise 5.3.
Do you want us to complete the table?
Yes, please.
So do we divide into 5, or is it like from the first one, 41?
Divide them all by 105.
Yeah.
Yeah. So this one will be 1. This will equal 1.
Yeah.
Whenever you're dealing with decimals, your probability in total will equal 1.